Welcome to the podcast Corner of Special Education. My name is Karsten Skrulle Gundersen, and I wish you a most warmly welcome to my Corner of Special Education. In this extra episode, you will hear my conversation with Duncan Astle, a developmental cognitive neuroscientist and Professor of Neuroinformatics in the Department of Psychiatry. Mr. Astle is also a program leader at the MRC Cognition and Brain Sciences unit, where he leads the 4D research group. I contacted Mr. Astle to learn more about his work and about his research, using multiple methods to explore how brain systems develop through childhood. How does the brain gives rise to developmental disorders? How do child development and environment impact each other? And what is transdiagnostic? These topics and more are discussed in the following conversation with Duncan Astle. Here we go. Excellent. With that, I would like to welcome to the podcast Corner of Special Education and a new episode in the series Let's Talk About. And as the title of the episode indicates, we're going to talk about developmental disorders and the way of diagnosing. And I'm always trying to figure out a good title for the episode that it gives proper information. So I don't know if today's guest would say that it's a good description, but we can get back to that in just a while. But with that, I always have at least one guest with me, and today's guest, why don't you give a short introduction of yourself and your work?
Hi, Karsten. I'm very grateful that it is in English, otherwise I would be in trouble. So my name is Duncan Astle. I'm a professor at the University of Cambridge in the UK, where I've worked for almost over 12 years now. And I'm a scientist primarily, and we study the developing brain, and we study that in lots of different children who have different difficulties. And I'll say a bit more about our work in a minute, but I guess our overall kind of philosophy is, the thing that really fascinates me as a scientist is, how is it that the organ between our ears starts off from such a kind of simple and kind of common starting point, that over the course of childhood and adolescence into early adulthood, we end up with these incredibly diverse outcomes. And that just fascinates me. And so really the core thing that I'm trying to understand better as a scientist is where does that diversity come from? And what does it mean for our experience of education or experience in the world around us? And I've been studying that for about 12, 15 years.
Okay, excellent. And what brought you into that that interest of why did you choose that way for your work?
Gosh, that is a big question. I guess so. I actually did my PhD a long time ago, but focusing actually just on adults. And it was a really fun PhD. We would recruit students, undergraduate students. We would strap electrodes to their heads, and then we would get them to perform these different tasks that we designed really carefully, and get them to switch between doing task A and task B and then switch back again. And it was really, really enjoyable. And I learned so much about how you design experiments, how you draw inferences about what the brain is doing and how the brain solves tasks. And when I finished that, I felt like I was in a really good position to use those skills and start applying them in different contexts. And I actually was torn between either studying older age and things like neurodegenerative conditions like Parkinson's and dementias, or to shift earlier in life and start to try and understand how it is that differences emerge between individuals as they develop. And in the end, it was really close, but and then that's kind of the route that I chose to go. And I guess the reason for that was just partly because I guess I knew a lot of kids who had really difficult times in school. And so for me, it seemed so impactful to try and understand why it is that we all process the world in different ways, and how it is that that has implications for education.
Mm.
And in the end, that kind of drew me into wanting to explore that more as a scientist. And then really it snowballed from there. Like I did like a fellowship on that. And then I started to build a team on that. And then it's such a popular topic that soon we found that there are lots of people who were really interested in our research. And we, as a team, we soon grew. And now there's probably about 15 of us at any one time working on related topics.
Excellent. Well, I have, probably welcomed you to this podcast. So thank you very much for taking the time, and for in your busy schedule. And I know that you are just a few weeks off to your parental leave. So thank you very much, and I hope
Pleasure.
that goes all well. Now, the reason why I contacted you in the first place was that I noticed that your name and your work were mentioned at the site of the University of Oslo and the Faculty of Education there. So I started to do a little bit of research, and I wanted you to just to get to know a little bit more about your work and also the work of your group. So, for the listener and myself, you tell a little bit about the work of the 4D group. What it is.
Yeah. So 4D stands for Development, Dynamics, Disorders, and Data Sciences. And really, we chose that name together as a group because it really sums up the kind of intersection of the things we're really interested in. And so at the heart of the group, I guess, is a kind of analytical approach, probably kind of the data science. And
Mm,
let's imagine I scanned your brain and I built what we call a connectome or a model of how your brain is wired up, like which areas are connected to which areas. Could I run a really simple simulation starting from nothing or a very simple network and adding connections over time to simulate what your brain looks like? So could I reverse engineer the way that your brain is wired
mm,
up? And again, if I can do that, might I learn something really fundamental about how it is that a brain changes as someone's developing? What are the
mm,
forces that act on a brain as it's emerging and organizing itself? And so at its heart, our group, I guess, is trying to use tools like that to better understand developmental processes of the human brain. But we then use that to try and ask questions about diversity and difference. So how is it, for instance, that everyone starts off from quite a similar position, but that as we develop, people steer off down different trajectories? And where is it that the diversity comes in and forces
mm.
change? For instance, genetic influences, environmental influences. And how is it that they're changing the constraints that act on the brain as it's forming? And then finally, sometimes those trajectories involve someone experiencing cognitive and behavioral barriers to learning in school. And so what happens in the particular instances where, for instance, someone experiences memory difficulties, and that makes it really hard in the classroom? Like, what is it about their brain that's emerged in such a particular way that means that they experience those difficulties? And so the kind of 4D kind of acronym for us was a way of kind of bringing together the methods that focus on development, the idea that it's changing and dynamic, but also the idea that there's massive diversity. And sometimes it's useful to label some of that diversity as a developmental condition or disorder.
I must say, when I saw what the acronym 4D stands for, I really liked it. So I think it was very, very interesting to do the preparing research before this conversation. But in here, how does the brain give rise to developmental disorders?
Okay, that is a big question. So one helpful framework right from the start is to distinguish two very different types of developmental disorders, right? So one is what we traditionally would call rare developmental disorders. And they tend to be genetically caused. And when I say genetically caused, I mean that we can identify a gene that has caused them. Sometimes those individuals will get a diagnosis of something like intellectual disability. They may pick up other diagnoses as well. And for an increasing number of those children, we are discovering the gene that is causing that disorder. And the reason we're able to discover the genes for those disorders is usually because those children miss classic developmental milestones very early on, right? So there's a kind of category of developmental disorders that are caused by a gene, often a single gene that's been mutated, and we detect them relatively early. Those kids will often receive a diagnosis of intellectual disability, and increasingly we can say this is the gene that has caused it. So that is one thing that causes developmental disorders is genes that get mutated, right?
Yep.
Second category, which I think is the much bigger category, which is the one that we focus on a lot more, which is what I would call common neurodevelopmental conditions. Your ADHDs, your dyslexias, your autisms, your developmental language disorders. Where do they come from? And my view is this: there is no moment in development when suddenly, like, bang, ADHD happens, bang, autism's happening now. There might be points in development when we say, right, from, I don't know, 7 till 9 years of age, that's the most likely moment when a child is likely to get a diagnosis of ADHD. But the reality is, I think, that in those common conditions, their brain is developing under a subtly different set of constraints to their peers. The way that I would think about those is there is no simple genetic cause, right? There is no single gene for ADHD or for autism in that category. But in reality, essentially, it's different people's brains is developing according to different underlying constraints, genetic and environmental constraints, and that shapes the way that they organize and wire over time. And that creates massive amounts of variability in what we would call phenotypes, but what people's brains and people's behavior looks like. And in certain cases, we can categorize that kind of behavior as being different from what we would expect. Like, that child is highly inattentive, they're highly hyperactive. And so we would choose to give them a label. We would give them a discrete categorical label, ADHD, right? But that doesn't mean that in developmental terms, there is some special discrete category of developmental processes that always lead to that kind of condition, right? So I don't think there is a moment when ADHD happens, bang. We might detect it most when someone's age 7 to 9, because that's when those symptoms start to really stick out from their peers. But I think there is no particular moment. It's just that throughout development, the brain has been organizing according to a slightly different set of genetic and environmental constraints. Certain patterns of behavior become really recognizable to us, and so we categorize them and we say, right, that is a condition based on those behavioral characteristics. But I don't think that means that there is like a single cause that gives rise to someone having ADHD. I think, in fact, all the studies to date have really shown that there probably isn't a single cause that underpins having something like ADHD. But there's more what we could call kind of common neurodevelopmental conditions. I think they're just an aspect of diversity in human phenotype, in human existence. And that sometimes it's really useful to be able to label them and categorize them. Other times, no.
Yeah, if you can give some key points, how does this group respond to intervention, and what kind of intervention?
Right. I think it depends upon what you think the intervention is doing. Right? If the goal is this intervention will fix insert label of of the disorder category, my experience is that is extremely rare. Right. So we spent a lot of time actually doing some studies on something called cognitive training. Right. So we try and find, like, what's the area of difficulty in this group of kids, and then let's hit it with an intervention, train that thing up, and then surely once we've fixed that thing, the kid will then, proceed typically at school and everything will tick along very happily. Those studies just almost never work, right? And that, I think, is because there is no single one thing to be fixed that will then sort of yield cascading benefits, right? So, for instance, in ADHD, we spent a lot of time training executive functions, training memory, and none of it really did anything other than make the kids very good at the games that we were giving. But other than that, there wasn't really any benefit. And so gradually, I guess I've come around to the way of thinking that at an educational level, actually the most important thing isn't to focus on like, how do we fix the thing that we think is going with this kid? And instead, I think it's to decide, right, how is it that we create a learning environment in which this kid can still access the same quality of education and experience that everybody else can? And that's not to say that there aren't some good interventions. I think some really nice language interventions, for instance, that are really good for kids with developmental language disorder. But I don't think they work because they're fixing something, underlying their language. I think that they're providing an incredibly enriching environment that optimizes the improvements in language that kid makes. And so I guess maybe controversially, my approach to intervention should be, our goal here isn't to sort of fix something. There's also then who decides what gets fixed and what doesn't. But instead should be to say, like, what are the barriers that this person is experiencing in the classroom? And is there something we can do that would minimize those barriers?
Yeah. And I think that, because I recorded just like for say 10 or 14 days ago, I recorded a special episode regarding dyslexia that I will publish it in around October, which is the dyslexia awareness month, even September, October, yeah, around there. And so you can talk about when you prepare education for a classroom or for pupils, that instead of going in the wider direction, you go narrow. So it's easier if you plan to hit or to prepare or to give a lecture in a narrow way, to then hit in a broader way, and then the opposite. Any thoughts about that?
So there's like a practical side. So as a scientist,
Yeah.
I'm really always like, how is this kid different from that kid? And it's kind of very precise and kind of nuanced way. If you're a teacher in the classroom and you've got 30 kids in the classroom with you, and you're trying to think, how do I set up a lesson so that no one is left behind, right? You haven't got time to be delivering some bespoke intervention for, little Susan on the front row and then Jimmy on the back row. He needs something different. And so the practical challenge is that the stuff we do in the classroom to help kids who have a neurodevelopmental condition of some kind has to be scalable, right? It has to be practical. And so we produce a series, a guide called Belonging in School, which tries to guide schools through the process of making their own inclusion policies. And one of the key kind of recommendations of that is to think about universal approaches. And there are some education systems around the world, like in New Zealand, for instance, where they think really carefully about making things universal. So a classic example would be this, right? Kids with working memory difficulties often go off task mid-lesson because they forget what it is that to be doing. And so what teachers sometimes do is produce these little slips of paper that have kind of bullet points of like, these are the things you're working through. Have it next to you. If you lose track, then look over, see where you're up to, and cross things off as you go. Right? If you're making that for Susan on the front row, just print a copy for everyone. Just give it out to everyone. Right? There'll be a bunch of kids in there who you don't know, but they probably also get benefit from that. So just make it available to Jimmy on the back row, he really fidgets a lot, and there's a fidget spinner that he uses that he finds really helps him. Just have a box of them at the front end, right? Anyone can come and get them, right? And so I guess my approach is to think not only about like what is useful, but also what is practically scalable from a team perspective. And thinking about how you might make an accommodation that's there for one kid and benefiting one kid. How can you just make it all universal? Exactly.
And at your site, you mentioned child development and environment. So how does the latter impact on the first one?
That's a good question. So if we take an enormous step back for a second and say, like, what is special about human beings? And one of the things that's really special about human beings is that our brains are enormous relative to the size of our bodies, right? And then it turns out that actually our brains are exactly the size you would expect them to be given how long it takes them to develop. It's not that human brains are big, it's that they develop incredibly slowly relative to other species, even relative to something like chimpanzee. And you might think, well, why is that? I mean, what a design flaw that the human brain develops. So I mean, like giraffe or something comes out of its mother and it's just up and running around like that. And whereas a human baby arrives and it's utterly useless for years, right? And so why would you do that? And the answer is that by having an incredibly elongated developmental process, it allows for maximum adaptability to its environment. And lots of computer simulations show that if you have a system that has an explosion of synapses like the human brain, and then an incredibly slow pruning over time, you end up with an incredibly efficient system. So what we sacrifice in terms of kind of being ready to kind of get up and go as soon as we're born, we gain from having this incredibly adaptive system. And of course, the challenge of that is that if a child is growing up in a really adverse environment, then that will shape the way that the system is forming. And so one aspect of that we study is early life adversity. And so we tend to do that in large cohort data. And that is because thankfully, it's relatively rare to have such an adverse childhood experience that we can detect it in our studies. Whereas if we study, say, 10,000 individuals, we will find some people who had a very awful life experience. And it turns out that there's sort of different categories of bad experience that may well shape the brain in different ways. And so, for instance, one popular theory is that certain types of adverse experience that are threatening and shocking will really shape systems in your brain that are involved in emotion regulation or processing emotions. They will make you sort of hypervigilant. Conversely, early life adversities that are really more about deprivation, the absence of expected influence, the absence of kind of nurture and care or resources, they will have a knock-on effect for kind of aspects of cognitive denial that are involved in emotions. There are others who disagree with that theory, but that's one popular theory. And so one thing we explore is how is it that different types of learning environment might shape the kind of experience that you have.
Correct. Now, for those who have listened to this podcast earlier and also the either the Norwegian or the English episodes, they know that the last two, I have two irregular questions that like ends the conversation. That we are not there yet, but I just want to mention them. It's the first one is what you want the listener to remember from this talk. That's the first one, and the last one is tip of the day, which could be a podcast, movie, book, article, website, you name it. So we're not there yet, so I'm just mentioning it. But transdiagnostic. You write about this on your site, and it says that the purity of diagnostic categories and several routes to the same set of systems. Could you elaborate on that?
Yeah, I guess it reflects. I mean, back in the day, if you were interested in studying a kid's, the way that you would do it is you'd go along to your friendly clinician who runs a clinic near where you work, and you say, "I want kids with, insert category, ADHD, for instance." And they would then hand out your packs to the kids that come to the clinic. They would come, you would group them together, and you'd recruit a group of control kids who don't have ADHD, and you compare the two groups on maybe a task, maybe you put them in a scanner or whatever. And you want to find the difference between the groups. And you infer that whatever the difference is that's the cause of ADHD, obviously. And I think we've increasingly realized that that is a very limited way of thinking about what ADHD is. Because incredibly, it turns out, of course, the kids that you're getting through the clinic are all different from each other, right? And if you have the time to look, you realize that actually they're all very, very different from each other. The other thing that you don't get from that approach is that you don't realize that actually the kids that you're recruiting from the clinic are not always typical of kids who meet the criteria for ADHD, right? There are lots of kids who never make it to the clinic. there are also lots of kids who would meet criteria, not just for ADHD, but maybe for a reading disorder or a language disorder or something else. But traditionally, you wouldn't be able to study them. You'd have to exclude them because you just need kids with just the ADHD diagnosis. And so gradually, you can see that the impression that that approach gives you about human development is incredibly narrow and often misleading.
Yeah.
And indeed, when you use that then to inform an intervention, it turns out the intervention doesn't work very well. And so the whole idea of sort of taking a transdiagnostic approach to saying, well, let's put the diagnostic label the kid has to one side. And instead, let's focus on this broad mixed population of kids who all have some area of need that's relevant to the thing that I'm interested in. They may or may not have a diagnosis. They might have multiple diagnoses.
Yeah.
But let's focus at that level.
Yeah.
And that generally is the approach that we take in our research.
Correct.
And it's not to say, I should be really clear, that's not to say that I think that's because a diagnosis itself is not important. Like the families that we work with, often that moment of professional recognition where a clinician says, oh, you meet the criteria for insert label here.
Yeah.
That is such an empowering moment for them, for their families. It helps them lever additional support often. It helps them kind of find their tribe, their people they can relate to.
Yeah.
The challenge as a scientist is should I treat those labels as sort of reflecting some discrete underlying cause? And I think the answer is no. And also, if I were a teacher, would that label be enough to inform me how I should support this kid?
Yeah, correct.
And I think, again, the answer is no, right? So it's not at all because I think that the reason we're kind of into this kind of transdiagnostic thing is not because I think diagnosis is unimportant, not at all. I just think that there are limits in the ways that it is useful. And that the question should be like, what comes next?
Yeah.
And that's where we're focused.
But why, in the first place, you have in a sort of way talked a little bit about it, but why do we need, or why do we give diagnosis?
Wow, that's a big question, right? All sorts of reasons, right? Number one, so certainly in England, not in Scotland, but in England, if you want support for your kid, they need to have a diagnosis.
Yeah.
So we've used diagnosis as a way of rationing out support. Actually, in Scotland, it works differently, but many systems around the world, we use the diagnosis as a way of rationing out support. And then the second thing is, we tend to borrow a kind of medical model, right? So these kinds of conditions sit within a broader framework where we try and categorize difficulties so that we can say, right, you have insert label here, right? And that's important because in lots of medical systems like the USA, for instance, if you do not have the diagnosis, then whoever did it cannot bill the insurance company for that process. And that is a crucial thing, right? So that I think is a very strong ingredient that has driven us towards this particular system of categorizing individuals and giving discrete labels. Because there are very strong forces that drive us down the route of a kind of medicalized model.
Right. Now, I don't know how it is in the UK and in the US, but here in Norway, the rise of dyslexia, and ADHD and autism diagnosis of that group is on the rise. How is it in the UK?
Yeah, similar. There is gradual expansion in the number of kids who are trying to access those kinds of needs. The perennial question that people often ask is, like, what's driving that increase?
Yeah.
Is it are there genuinely more kids experiencing those difficulties, or are there other factors that are driving the rates up? And who knows? Because it's very difficult to say. But I think the likely answer is the second of those. So much more awareness on the part of parents, different expectations of parents on what they expect for their kids from school. There's much less of, little Jimmy on the front row is not good at reading. I guess that just happens. Parent is much more likely now to say, or the teacher's much more likely to say, that's not typical of what I would expect in a classroom. And so I think we should investigate this further. Right? I think that is much more likely now than it was. Secondly, you used to get a lot of what is called diagnostic overshadowing, where a child would get a particular diagnosis, and then everything that that kid struggles with is inferred to be a result of whatever that diagnosis is. The classic, for instance, is that if you look at diagnoses of intellectual disability, or the other terms that are sometimes used for that, they're gradually declining, and diagnoses of things like autism or something more specific are gradually rising. So changes in the way that we're giving out diagnoses, I think, also explain some of the rise. But of course, it's also really hard for me to rule out that there is some hidden factor out there that's causing reading difficulties or that's causing more ADHD. But I think the biggest thing is just changes in the way that we detect our awareness of and our approach to identification is probably what is changing.
Yeah, and also I think that including all of the key points that you mentioned right now, that also the knowledge for the parents and for the us that work in school, it's more knowledge about the different types of what's typical and the criteria and what to look for in the ADHD and all these more new developmental disorders.
Yeah, I agree.
Yeah,
I agree. And I think that changing culture is a big part of the changing numbers.
Yeah, absolutely. It's it's an acronym from the Swedish professor, Dr. Christopher Gillberg. And one of it's an acronym for all of them, like ADHD, autism, dyslexia, that are neurodevelopmental diagnosis. And he said, and that you mentioned it earlier in this conversation, that if you have, it's more likely that you have multiple diagnoses rather than one singular. And he's in a presentation he had, I watched on YouTube. He said that if you have like ADHD, it's more like the rule that you have something else as well, rather than just one singular diagnosis. Any thoughts about that?
Yeah, I agree with that. I mean, that is the reality, right? So kids that we see often have multiple diagnoses or would meet criteria for multiple diagnoses. Which makes it even more ridiculous that for a long time we would exclude kids with co-occurring diagnoses because you wouldn't be able to publish the paper because the reviewers would say this is not a pure sample. So you can't be sure that what you're studying is whatever the diagnosis is. And so it's taking quite a while, I think, for us to break out of that framework and include kids with co-occurring diagnoses. But it's certainly the case that for me, it's a phenomena of whenever you take something that ultimately is part of natural variation, that there's what we would call kind of common neurodevelopmental conditions, I think are part of natural human variation. That doesn't mean that you shouldn't at some point try and label them and give support to those people who deviate in that way.
Absolutely.
But thinking about it in those terms makes it really obvious that, of course, if you're deviating from a kind of expected trajectory in one way, you probably will encounter a whole series of different symptoms that might result in you getting multiple different diagnoses, right? As soon as you move away from the model of saying, oh, this neurodevelopmental condition is caused by this thing that goes wrong when you develop, right? As soon as you move away from that and think this is all actually part of a series of overlapping, naturally varying processes, you suddenly think, well, actually, it probably will be more likely that you could pick up multiple labels along the way. And the other really kind of important thing to think about is that sometimes these things have knock-on consequences, right? So let's say, for argument's sake, that a kid really struggles with inattention and hyperactivity. And that means they get an ADHD diagnosis. But it also means that in their school, they're not really well set up for supporting that kid. So he often gets sent out. He spends a lot of time out of class. And so he wasn't a great reader to start with, but now he's also missing out on a lot of reading opportunities. And so down the line, he now starts to be a really poor reader and starts to pick up a specific learning difficulties diagnosis. And so it starts to get complicated because you realize that developmental difficulties can cascade and knock onto each other. And that's another reason why I think it's really important to focus on the intervention on, rather than what I think is sometimes a bit of a waste of time trying to think how you kind of correct something in a child. Better to think about how is that being a barrier and how do we make sure that that doesn't be a barrier anymore? Because if we're not careful, this kid is going to get totally switched off from the education system, and that will only cascade over time. So I think this idea of, your co-occurrence is the rule and not the exception. It's just a natural part of normal developmental processes.
Correct. And we are closing in on the end of the session. What do you want the listener to remember from this talk?
Oh, good question. I think for me, the big thing, I guess I spent a lot of time doing teacher training and being in teacher conferences. And something that, at least in the UK, that kind of comes across is that teachers spend a lot of time training in different ways. But sometimes that are surprised when they get to the classroom and they're all suddenly confronted with just how much variety there is within the classroom. And I think for me, the biggest thing is that variety is a direct consequences of what makes us special as a species, like the diversity and the processes that result in this incredibly powerful processing thing between our ears. And so I guess my biggest kind of take home would be diversity and differences between people is not a bug. It's not a mistake. It is an important design feature that has made us especially good as a species. Not say that it's not challenging from an education perspective.
Don't
think you're going to correct it, and I don't think you're going to fix it. You've just got to find ways of accommodating it.
Excellent. And you have a top day from the end of this.
Yeah, top tip of the day. I would say if you haven't yet, there's a really great school level intervention which has come from the University of Edinburgh called LEANS, which stands for Learning About Neurodiversity in School. And it is a whole school intervention. It includes like storybooks, materials for the teacher. And what it tries to do is introduce the concept of this diversity that exists in human beings and educate the whole school about the different things that different people need to succeed. And it normalizes the idea that kids will need different things to succeed. Like little Jimmy needs to get up and walk around every 20 minutes, right? To stretch his legs, right? Then he can concentrate. And I think that is such a great approach to start young and to involve the whole school to educate one another about the differences that they will encounter in schools. And they've done such a beautiful job of putting it together, and it's completely free to use. And so if anyone's out there who's a teacher or works with kids who's thinking like, what would be good for my kids who are experiencing neurodivergent differences, LEANS, Learning About Neurodiversity in School.
Excellent. Well, Duncan, with that, we are at the end. So again, thank you very much for taking the time and to be a part of my little podcast. And I wish you all the best, and also with your forthcoming parental leave, and also happy summer.
Carsten, thanks very much. Thanks for having me. It's been a real pleasure. Thank you.
Thank you very much. That concludes this extra episode. But before our ways part, remember to follow the podcast on Spotify or where you listen to podcasts. Also, remember to follow the podcast on Instagram and Facebook. Also, if you want the latest news and posts from the blog, you can sign up to the newsletter from spaceblog.no. If you have any comments or want to get in touch, don't hesitate to send me a PM or email at question@spaceblog.no. As always, I really appreciate if you rate, share and recommend the podcast. Finally, thank you to all of you who have listened to this episode, and a warm welcome to new listeners and followers. And a special thanks to Duncan for taking the time to join this episode. I hope to meet you again in next episode of Corner of Special Education. Until then, take care.